the last part of chapter 1 we didn't cover last time, which is linked libraries and functions. So if you have a library, it has a bunch of functions you might want to use, like math functions or graphical user interface functions or cryptography functions, that sort of thing. So you must link it to the main executable. And there are 3 ways to do it: static, at runtime, and dynamically. Static linking is common in Linux and Unix, that it's wasteful of space, hard drive space and RAM. We put a whole copy of the library attached to the program. And then if another program uses the same library, it gets its own fresh copy of the library, all the code attached. So if you have 1 megabyte program and a 10 megabyte library, your program is 11 megs, and the other program is also 11 megs. So you have extra copies of the library running in memory. So it wastes memory, but it's clean and sanitary. Each program has their own library. They're not shared. So that's one way to do it, but almost never used in Windows. Runtime linking is unpopular in friendly programs, while malware does it, where you only connect to the library when you need it. Now, I have seen this in Microsoft Office 2010. I don't know if you're using the latest version. You would install Microsoft Office like Excel, and then when you went for features on the menu, it would say, oh, you have to put in the installation disk. I didn't bother installing that stuff until you tried to use it. So that's the kind of thing. It's also possible, but the most common type is this one, dynamic linking, DILs. And this is the one that has this feature, which if you've been using Windows for a while, you remember all the way back, Windows 95, Windows 98 would constantly pop up a box saying, I can't find x4793.dil. Because what's going on here is when you install a program, it will install these libraries that it needs, but when you uninstall it, Microsoft doesn't know if you're done with the libraries or not. So at least until recently, whenever you uninstalled something, Microsoft could ask you, should I delete x74392.dil? Yes, no. And everybody has, I don't know what you're talking about. And they give it a random answer. And now, by the way, Unix solved this problem in the 70s, like almost every problem. There's a thing called the link count on a file, which counts how many other files are using this file. And it knows when the link count falls to 0, I can delete that file. But Microsoft did not get the memo. So anyway, that's why you have this problem that still pops up in modern versions of Windows where DILs are mysteriously vanishing. Anyway, so the portable executable header has to list every library and function you're going to load. So when it loads, it can find those library functions, and it will see if some other program has already loaded them. And if so, it'll just connect to the running instance of that library. Otherwise, it'll load it if it can find it. And the names often are quite descriptive, like URL download to file. It's pretty obvious what that is. All right, so if you want to diagnose these problems, missing libraries, missing links to libraries, which are extremely common in Windows programs, there's a tool used called Dependency Walker. And it shows you how what's dependent on what. So services.exe uses all these libraries. And malware, however, uses just a couple libraries. This is extremely abnormal. A normal program uses tons of libraries. So this is a fake services that's just a piece of malware doing very little. This is kernel functions, and this is, I think, networking functions, WS232. Anyway, so you can see the imports and exports. So here's one of the malware samples running, and you go to this library, and the library has exports. Exports down here. Those are functions it offers for you to use. So things like pinit, whatever that is, and Commodore or something. These are the functions. So the functions it offers, a lot of exports. Now, then it has imports, which are functions it uses in another library. Libraries typically use other libraries, and it goes on, and this is the way it's been for a long time. This recently has led to a lot of concern in the security world because of the SolarWinds attack. About 3-4 years ago, the Russians hacked into SolarWinds, which is a commercial product used to remotely administer servers, and they poisoned the development process, so the official update included Russian malware, placing them under control of Russia. And people installed it and got infected, tons of American companies. It was really nasty, and this began to open everyone's eyes to supply chain attacks. If you run software, your software is using libraries, those libraries are using more libraries. If you're using something like Python, you just import these Python libraries from online repositories, which are just coming from foreign countries, developed by God knows who. Some drunk in Finland wrote this thing. You don't know what version it is. You don't know how old it is. You don't have any reason to believe it's not infected with malware. And in fact, criminals do contact people that write popular software or popular browser extensions and offer to buy it from them so they can put malware in it. And nation states compromise these development environments that are often not very secure. So it's actually a big issue these days. Where did all the code you're running come from? And how secure is it? And now they're trying to get software bill of materials on every code run on government machines and other high security machines where you know everything that's running, which is not simple. Anyway, so here's some common DILs. Kernel32.dil gives you core functionality that involves kernel permissions like manipulating memory and hardware. Here's the API, which gives you Windows components like Service Manager and Registry. Here's user interface like buttons and scroll bars. Here's GDI for graphics, graphic display interface. These are common libraries. NTDIL is the interface to the Windows kernel. This is called the native API. What you're supposed to do is import kernel32 and use those functions. But all kernel32 is going to do is call NTDIL. NTDIL is the low-level, largely undocumented kernel, but as you're going to see, if you get a debugger, Microsoft doesn't matter whether you document it or not, you can totally figure out what every piece of Windows is doing, and people have. So if people want, malware authors often directly use the native API and NTDIL passing by the other way to obscure their code and trick anti-malware. Then there's Windows Socket. These are networking DILs that make network sockets. And then WinINet is a higher level DIL. These are the ones from old BSD Unix. BSD Unix invented the Internet Protocol. It was the first Internet, all using BSD, and everybody else reluctantly imported the BSD functions into Python and every other language, and these are the BSD network socket DILs, which underlie all networking. But normally you use this high-level thing that will have a, here you have to use things like accept and connect and listen and capture the packets one by one, which is ridiculous. Typically use WinINet that has a nice high-level function like download URL to file, which will take care of all the networking. It will do a bunch of calls to the lower-level API. So once again, a malicious author might directly call these things to have a strange networking activity that is not standard and to escape inspection by malware analysts that are looking for the normal calls. So DILs export functions. If you have a library, you're offering a whole series of functions, and you export all those. Those are all different entry points into your function. EXEs import functions, and they typically only have one export, which is the start. You're only supposed to start them at one place and then run it. So that's how it looks. So here's notepad.exe, and here's its import address table. And as you can see, it imports a lot of things. Registry query value from advanced API. Then from some other library, it's got these things here like map view of file, local unlock, get local time, and so on. Even the simplest program like Notepad uses many, many other functions and library calls. Here's advanced API.dil, and this is the export table. So it is exporting all these functions, access check, and add access allowed, and so on. And this is just the A's. You can see from the scroll bar, there's hundreds, maybe thousands of functions in this library. And that's how Windows code works. You just call all these libraries in Windows API to control it. Here's iTunes setup, an EXE, and you see over here what it looks like in binary. All Windows executables start with MZ, and then they have this phrase, this program cannot be run in DOS mode. This stuff is all boilerplate. And then they'll have other sections down here, text, RData, data, resource, and relocation. And then they'll have an import address table. And somewhere, I think they'll have an export address table. It doesn't really matter, just one entry point. Anyway, that's the sort of thing you'll see, and we'll play with this pretty soon. You'll be analyzing programs that way. So, if you have a keylogger that's watching for key presses, it could import user32 and set a hook, which will run code every time a key press goes down. All right. It's then going to send the data somewhere, and it could use register hotkey to define a special keystroke to harvest the data. These are some things you might find in a keylogger. If you have a packed program, then it's all compressed, and all you're going to see is the unpacker. So you'll see very few functions, very few libraries, because all you're seeing is the unpacker. The real program is packed and out of view. All right, let me check for comments on the switch. Good, nothing new. Okay. All right, so the PE file header and sections. Text is where you have assembly language instructions, really machine language instructions for the CPU to execute. So it's not anything readable text at all. Here's imports and exports are in the R data section, and global data is here, and strings and resources. And there can be any number of additional sections, but these are the ones you'll almost always see. So PE view, if you look at Notepad, will show you Notepad has text, data, resource, and relocation. All right. Now you've got a time date stamp, which shows when this executable was compiled if the compiler actually fills it in. There are some languages that all Delphi programs claim to be a 92 because it doesn't fill it in correctly, and it can be altered anyway. But this is one tip that a lot of people use for attribution. They find out you have a whole bunch of malware, you find out when this malware is compiled, and you find out it's like working time in America or working part of the day in Russia. And therefore you get some idea like what time zone it was done in, but that's pretty sloppy. All right, you got virtual size, which is the RAM it's going to use, and raw data on the disk. Typically these two are similar for a section. Packed executables, which are a virtual size much larger than raw data, because the raw data on the disk is packed and it has to unpack it to put it in RAM. So here you got a virtual size of A6HC and a size of raw data of A800. This is what you'll see for a normal program, like Notepad that is not packed. These two are approximately the same. This is the size in RAM, and this is the size on the hard disk, and they're typically the same. All right. And here's packed one, where you have virtual size that's big, but the raw data is 0 because all the packed data is in some other section. It's going to be unzipped and loaded into these multiple sections here, and we'll see that as we go through the projects. Resource Hacker is an old hacking tool that lets you play with things in the resource section so you can change the appearance of games and such. Typically strings, icons, and menus, not major functionality going on there. And that's what it looks like. You can see all these objects, like this is calculator. And so here it's got various icons and screens used by calculator, and you could replace them or modify them. Not that that's very important, but some people use it for other functions too. Anyway, let's try another Kahoot, which is here. All right. All right. It's certainly going to be an election year. There'll be a lot of nonsense going on. All right, what technique makes an executable large? Static linking. means it has extra copies of libraries. That makes it large. What's the most common technique for executable Windows software? Dynamic linking, good, a popular answer. All right, so which library is required if you use FTP? Typically, you use win.net.dil, which understands FTP. In principle, you could use WSOC and handle the packets one by one, but that's really far too much work for most people. Any normal person using FTP would use win.net. All right, so which library is required if you want to pop up boxes and have buttons? Problem later. Yep, user 32 for the user interface. All right, so which library is not normally used by EXEs and may indicate that you are malware? Native API, not intended to be used directly by developers. I got them, although people with fake names will have to tell me who they are. All right, let me stop this recording.